Section 7.6, Part 3. This is starting with example 4. It says, and a certain item is manufactured by 3 different factories, 1, 2, and 3. So these are the separate partitions within the sample space. What factory 1 does is mutually exclusive from factory 2. We know that 30% of the items overall are made in factory 1, 20% are made in factory 2, and 50% are made in factory 3. Suppose 2% of all items from factory 1 are defective, 3% of all items from factory 2 are defective, and finally 4% of all items from factory 3 are defective. Assume that an item is selected at random from the stockpile is defective. What's the probability that it came from factory 2? So in other words, who do we blame when we know it's defective on the other end? Okay, so let's come in and make our tree. So the very first thing we have is the things that are mutually exclusive. So that would be factory 1, factory 2, and factory 3. And they told us that 30% of the items from factory 1 are defective, 20% from factory 2 are defective, and finally 50% from factory 3 are defective. So from there, we're going to go with defective and its complement, defective and its complement, defective and its complement. We know from factory 1 it's 2%, from factory 2 it is 3%, and from factory 3 it's 4%. Now, because they're not asking me for a complete tree, I'm not going to bother to fill in the rest of those branches, but notice you could fairly easily by just making sure the branches add to 1. So we're looking for the probability that it came from factory 2 given it was defective. So again, the left side given the right side. Left given right. So we know that that's going to be equal to the branching that starts at 2 and ends at D. Starts at 2, ends at D. So that's 0.2 times 0.3. Oops, be careful. 0.03. Do that. All over every branch that ends at D. So we'll do 0.3, that's the top branch, times 0.02, plus the branch that we already used, plus the bottom branching, which is 0.5 times 0.04. So every single branching that ends at D was picked up and summed in the denominator. Okay, and if you do that, I have that the numerator is 0.006, the denominator is 0.032, which ends up being 0.1875 as our final answer. So if we know that the item from the stockpile was defective, the probability that it came from factory 1 is 18.75%, or from factory 2 is 18.75%. So notice that's less than that percentage that comes from that factory. Okay, our next example gives this information in a slightly different format, a table. This is example 5. And it talks about a study conducted by the Metro Housing Agency in a Midwestern city revealed the following information concerning the age distribution of renters within the city. So we have the age, and we have 21 to 44-year-olds. We have 45 to 64-year-olds, and then we have 65 and over. So 65 and up. And we have percent of the adult population. So adults. Percent. So this is the percent of the overall adult population. This is 51%, 31%, and 18%. So you'll notice that these guys add to 100%. Then over here, we're going to have renters. So, and also percentages. So this is 58, this is 45, and this is 60. So what this is saying is that 58% of this 51% rent, 45% of this 31% rent. So there's a little bit different interpretation of what we're doing. Okay, we want to know what is the probability that an adult selected at random from the population is a renter. Okay, so the population that rents. Okay, so what we're going to come in and do, again, what this is saying is that 51% of the adults are in this age bracket, 31% of the adults are in this age bracket, and 18% of the adults are in this age bracket. So altogether, these are all the adults. So we're not looking at any kids or anybody who's not classified as an adult by 21 to 44-year-olds. So to find the number that are renting, what we're really going to do is simply come in and take and multiply the percent of renters times the age population for that group, that percent. So we're going to take the 0.51 and multiply it by 0.58. Plus, we're going to take 0.31 and multiply it by the 40.45. Dropped my decimal. Plus the 0.18 times the 0.60. And if you do that, that comes out to be 0.543. And I think you're probably wondering, why did she do it that way? Well, let's backtrack and look at this another way. So I'm going to call this bracket A, this one B, and this one C. So basically, we're saying the first branching on our tree is the age group of the population. So this would have been the 51% that make up this age group. This is the 31% that make up this age group. And this is the 18% that make up this age group. And from there, you either rent or you don't. You rent or you don't. You rent or you don't. So the renters were 0.58 of these. This was 0.45 of these. And this would be 0.6 of these. So, okay. Then you can see why we did this multiplying across. To get to all the branches that are renting, we had to multiply across and then add them down. So now it makes a little bit more sense, I hope. Okay, part B, you must know if a renter is selected at random, what's the probability that they're 45 to 64 years old? So that's B. That's what I call bracket B. So we're looking for the probability that you're in age group B, given that you rent. So notice the renting is our denominator. We need the branching that starts at B and ends at R. Starts at B, ends at R. So that's 0.31 times 0.45 divided by the probability that you're a renter, which we just figured out in part A, 0.543. So they're leading me to it very nicely in this case. That ends up being 0.257. So the probability that you're between 35 and 64, given that you rent in this small Midwestern city, comes out to be 25.7%. Okay, one more example, we'll call it good. This is example 6. So example 6 says, Teleview and Radon Corporation are competing for a contract to build TV equipment for a pro. They both have equal chances of getting the contract. If Teleview gets the contract, then the probability of a total success is 60%. The probability of a partial success is only 10%. Excuse me, if Radon gets the contract, the probability of a total success is 30%. The probability of partial success is 50%. If the contract is awarded and the result is a total success, what's the probability that Teleview got the contract? So they're asking me for the probability that Teleview got the contract, given that it was a total success. Okay, so we're going to come back over here. Our first branching, and again, these are mutually exclusive, is either Teleview or Radon gets the contract. They tell me that they have an equal chance. So in a roundabout way, they're telling me that each of these is 50%. Now from there, the branching this time is actually 3 branchings. You're either a total success, a partial success, or a failure. So let's call it F for failure, right? Excuse me. So same thing down here, total success, partial success, or failure. They tell me if Teleview gets it, it's a 60% chance of total success, a 10% chance of a partial success. Notice that that would then give me 0.3 down here for the failure. If Radon gets the contract, the total success is only 0.3. The partial success is 0.5, and the failure would be the rest of that, which would be 0.2. So even though they're worse off to begin with, they're definitely better overall. Okay, so again, what we need first is the branch that starts at T and ends at S. So that'd be 0.5 times 0.6 over all the branches that end at S. So all the branches that end in S would be that 0.5 times 0.6 plus 0.5 times 0.3. And I have that comes out to be 0.3 in the numerator over 0.45 in the denominator, which gives us 0.667. So the probability that the contract came from Tel Aviv, given that it was a success, is 66.7%. And that wraps up our probability. Next up is chapter 8, which is our introduction into statistics from a probability point of view.